Good morning, everybody. Thank you for joining us today for today's TopSolid What's New webinar with a key focus on 3D toolpath improvements. We'll just give people a few more seconds here to log on and we'll get fired up. As always, I have other team members with me here. They're available to answer questions. So if you have any questions, please type them into the question area of your interface, and we'll do our best to answer them either during the presentation or towards the end. Okay, so let's get started. So the first thing that we're going to talk about is a couple of little improvements. The first one being an improvement to how you manage the origin. Okay, this improvement is not necessarily a 3D improvement. It can be used anywhere in the software. So if you right click on your origin and go to edit, you'll notice that under the automatic positioning, there's a new button here called Edit Automatic Positioning. If I click on that, it brings up this dialog, which allows me to just change where I want my origin to be in a very, very easy manner. So you don't have to create new WCSs or anything, just use the automatic way of this system. Perfect. Okay, next, let's talk about new tool shape primitives. So as you can see here, I have a new type of ball mill. How did I get there? If I go into here and create a new ball mill, and this is available everywhere in the milling software, you can see you have 4 new primitive types. Okay, so this first primitive type is just your standard straight shank tool. This one is got the taper to it. This is stepping it up once. This is doing several steps up. So you can choose whichever one you want. For example, if I go to here, you can see you can control how it steps up, what sizes, everything. Okay. In this sample, let's go back into here. If in this first sample, I'm using this new tool primitive. Let me flip this around. And you can see that that tool primitive is avoiding running the shank of the cutter into the part. So that's kind of cool. How does it work? If I go into settings and I go to tool definition here, you definitely want to click on use tool shape, okay? And if I update this with the real values of the tool, and we click OK, let's let this crunch out once here. Now we're getting some collisions, and I'll explain why. It's almost done. Basically, when you turn on that operation, what happens is the software, if you're using just the straight tool sizes, the software is going to look at the exact tool shape and it will avoid everything. Okay. Now what happens when it avoids everything is that angular shank is going to come close to touching right up here. And what you can do then is in that tool definition area, you can basically kind of, let's call it lie about what the actual shank of the tool is. So you can add some clearances in different places of the tool. And this is fantastic. It looks like I've angered TopSolid. Alrighty. That's always fun. Oh, nope, look at that. All I had to do was threaten it. I was just being impatient. Okay, so let's watch the simulation. I'm gonna go down here and go to Analyze and Simulate from a Point. And we'll go maybe, I don't know, right there. That's gonna start the simulation. Simulation was going too fast, so we missed it. Sorry, we'll do that one more time. Happy Friday, everybody. Analysis, simulate from a point. Let's go back here a little bit. There we go. Okay, so you can see as this is coming around, we'll look at it right on from the side, that it is basically very close to rubbing on there, right? So the way that you get around that and avoid that is you come up here to Settings, you go to your tool definition, and here under the D2 value, which is this diameter, just give it some clearance. So let's say this is 14 millimeters instead. And now you see a little green section there. That green section is going to be the clearance section. You recalculate, and now you're going to avoid collisions on the angular shaft and there. Okay? Now, the next one, let's get rid of that toolpath for a second. This next one has to do with how to rest machine. Now, you can use the standard rest machining, but sometimes you don't want to use the standard rest machining. Sometimes you just want to create your own profiles, right? So let me hide this one. And what you can do here is, again, this is a new improvement. You go to Additional, you now have Sketch Tool Shape Rest Material. What happens in this one, let me expand this really quick. We select the part we were in question, you select the operation in question, and then you can hit Preview if you like. And the software is going to take the values from the operation, the tool sizes, any clearances you put in there, and it's going to generate all of the rest machining curves that are needed to finish where that tool couldn't reach. Okay? That creates the curve, and then from there, you click OK, you save the curve. You can use those in any of the 3D toolpath machining strategies. So just a nice little toolpath, or nice little feature to help find the areas that still need to be machined. All right, let's get out of that. We'll go ahead and validate that. And then we'll move on to the next subject, which is a couple of improvements to super finishing, in fact. So the first improvement, while this is finishing its calculation, we made a change, two changes to super finish. One is to only calculate the shallows. There you go, there's your sketch. Go ahead and close that out. So the first one here, let's go look at the fish. So if we go to super finish, and we go to super finishing type here, you can see there's two new options here, only raster and only constant step over. Okay, remember raster and constant step over in super finish are to machine shallow features. If we go and look in the settings here, it's machining everything from 0 to 45 degrees. That's the angular separation. The reason why we did this is because maybe you want to come back on the steeps with a different style of cutter. You don't want to use a ball mill. Maybe you want to use a bullnose mill. Okay. If we go look at another sample really quick here. Again, same concept. This one is just doing a raster pass instead. So I have it set to the raster mode right there. Again, angular separation from 0 to 45 like so. And you can see all the steeps are being ignored, and this is just hitting on all the shallows. So small improvement, but kind of cool. The next improvement to 3D is the super finish with radius mill. So for any of you that use super finishing, you're probably going to like this improvement. To date, super finishing has only ever worked with a ball nose end mill, and now, provided you are in angular separation mode, there's two modes here. There's material left and angular separation. So provided you're in angular separation mode, you now have access to a radius mill or a bull nose cutter, and all the rest of the command stays the same as it always has been. So off you go, and you have a bull nose driven super finish toolpath. Kind of nice. Okay, so speaking of cool improvements. We made a small little improvement to constant step over. I'm going to open up two little samples here. They're really, really simple samples. One of the main issues with constant step over toolpaths has to do with peaks and valleys. So again, constant step over toolpaths are better on shallow machinings. You can do it on some steep walls as well, but it's better on shallow. But when you get all the way to the peak or the valley, like up here or down here, it can't see that last toolpath. So it may leave a small little scallop there. So the little improvement here is just a new option, which honestly, I would set this in your defaults, add a last offset at the end, you activate it, and again, watch the peaks and valleys, and now you see there's a toolpath there and a toolpath there to get rid of that scallop. If we go on to this sample, just again to show a different type of geometry, let's go ahead and look at that as well. And again, you look up here, you're going to see it throws in the toolpath at the peak, and it threw it in here at the valley. So again, nice little improvement just to help with finishing. Let's go ahead and go on to the next one. All right, in Raster Passes. Oops, let me get rid of that. So when I open up this part, this was a toolpath generated inside of 713. Okay, and with Raster Passes, we did a couple of things. Primarily, we wanted to improve how the software sees hard edges or sharp edges of the model. Okay, so here you can see as I'm cutting across that sharp edge, so it's really going to roll over that edge. Okay, and when using contact surfaces, just to show you, if I go into here, this one we're doing machining with contact surfaces. So go to additional surfaces, and we have contact surfaces. So we're just machining these faces here. You can see that it is rolling up on the edge, rolling over on the edge. Again, it's not violating, but based on how machines work, you might break that edge a little bit. So I'm going to go up to here to edit, and I'm going to upgrade the algorithm. Because again, this toolpath was generated in 7.13 or before. So we're going to upgrade, those go dirty. Let's go ahead and regenerate. And then let's see what the upgrade does. So the first one you'll notice is on the contact surfaces. You see how we're stopping on the sharp edges. So we're doing our best to find that angular change and stop the tool from rolling over. If we go look at the bigger toolpath, notice we're doing the same thing. Anywhere that there is that sharp angular edge, we're now stopping the toolpath so that we're trying to save your sharp edge. I think that's a pretty awesome improvement, in fact. All right, let's keep going. All right, this next one should have everyone giddy. This one will take some time to go over because there's a few steps involved in it, but I want to talk about what it is first. So again, one of the goals was to give you tools to help you maintain sharp edges on your 3D toolpath. So if I zoom up on this thing, you can see my toolpath is coming up and following some additional surfaces, right? If I turn off my toolpath so you can see the additional surfaces, I have created surfaces all the way around that appear to be tangent. That's kind of awesome. Okay, now, how did I go about doing this? Let's have a look. So I'm going to delete my toolpath. I'm going to go ahead and switch to CAD mode. And let's go into here. Let's go to our shapes. I'm going to get rid of my tangent surfaces. That's fine. We'll get rid of that as well. That's fine. All right. And then I'm going to get rid of my sketch. I want to start everything from nothing. All right. So first, how do we make the tangent surfaces? So we begin with a curve. So I'm going to go under 3D Sketch here, and I'm going to go to Edge Copy. I'm going to be on Path Between Two Edges. And I'm just start working my way around the model, building my profile. Okay, so that's coming around. That came around all the way up to there. It's a little edge there. Let's make sure we get it. Perfect. Now we want to go that way. We want to go that way. That way. And I believe this will be the last one. Nope, one more. Okay, so we have our 3D boundary curve. Perfect. Now, how do we make the tangent surface? Well, thanks to a new surfacing command, and maybe you saw this if you watched the What's New in TopSolid Design webinar. So there's a new tangent surface command. Here's how it works. It starts by asking you to pick an edge. So I'm going to pick an edge. And notice it's just grabbing all the edges that are tangent. Then it wants a reference face. And then like that, it is going to be tangent to that face by that value. With create folder selected, it's going to create a folder to put these in. Now, what's really cool is we can just keep going around the model, selecting edges, and it's automatically going to select the right faces to be tangent to. Now, in some cases, you're going to get overlaps, and I'll show you how to deal with that here in a sec. So I'm going to go to here, there, and the whole reason for the surface is to help guide that toolpath from rolling over the edge. Let it roll over the top of the surface. That's fine. Boom, and boom. Perfect. Click OK, let it make everything. Now, the next thing that I want you guys to notice is you notice how each group came up as a different color. And the reason that did is because in my color settings here, if I right click on it and go to advanced options, I have random color for shapes active. Okay, this way it's going to roll through all of these different colors for each new set of faces. And why that's important is because now we can go through and identify where the surfaces are different to treat the edges, because we don't want to leave that there because that's going to cause the toolpath to do wonky things. So now let's go to shape. We'll go to reciprocal trim. I'm going to select here and there. That's great. Let's go down to the next color change. So here, if we zoom up, here you have a difference in tangency, in fact, okay? And it's because these faces are not tangent, so you have a little discrepancy there. Now, from my point of view, it's tiny and it's the overlap. I don't care, but if you wanted to fix it, you could remove that face and then just do a loft between the two. Maybe use that edge as a guide curve, okay? If I continue on my path, I go from here to there. That looks okay. Come on over. That one looks good. I don't think we have any treatment needed there. I think the next one is going to be over here. We want to flip that arrow. Perfect. Let's do the same thing over there. And I think we're nearly there. Flip that. That should be that. Now, before we go on to creating the toolpath, I want to fill in the gaps there. So I'm just going to make a little lofted shape there. Again, here, I don't think it needs to be perfect. It just needs to have a surface. Do the same thing over there. And now what I'm going to do is I'm going to, and this is, honestly, you don't need to do this, but I'm doing this to make the selection of the shapes simpler when we get to machining. So I'm going to sew as much as I can together. Notice the orange profiles. For those of you who aren't aware of what those are, that's showing you where the surface is open, okay? And that's because I have the preview turned on up here. If I keep going around here and I go back over to here, you'll notice the orange curves here where they come together. And that's, of course, showing us that those surfaces don't actually come in contact with each other. So we're not going to select this one to be part of that sewing, but maybe we can go this way. Again, not looking for perfection. I'm just looking for something that makes selection a little bit faster, a little bit easier when we get into machining. So that one's okay, that one's okay. Let's go around to here. Nope, that's got a deviation, so we're going to leave that. Then we can go with this one and this one to this one, and that's good enough. So we'll have 3 surfaces or 3 groups of faces that we can use. So now let's go back to CAM mode and let's make our toolpath. So I'm going to go to finishing, and in this case, I'm just going to use constant step over. Let's go to our geometry. First thing I'm going to do is set my bounding curve. So I'm going to go here and select that profile. Perfect. Now I'm going to turn off my preview for this next thing just so you guys can see the selection process a little easier. I'm going to go to additional surfaces. I'm going to activate that. And now I'm going to go select that group. And you notice it highlighted the whole group, which is perfect. I'm going to go grab this one next. Making sure that's right. I'm going to grab that one. And now everything is selected. And we'll click OK. And like that, now the software is going to do what the software does. It'll calculate the toolpath, and it's going to use those tangent surfaces as a way to extend the toolpath in a more natural way to keep those edges as sharp as possible when the finishing is done. And let's have a look. And now you can see how that's extending up to those surfaces, and life is good. Hope you guys will enjoy using this new command. Okay, let's move on to the next one. Next one is another improvement to check surfaces. I suppose I could have done it right in there, but I didn't. So if we look here, I'm going to delete this. Let's just start a new finishing command. And we'll go to geometry right away. And we'll go to additional surfaces, and we're going to go to check surfaces. So here is the first new improvement. First, you'll notice you have something called new empty group. If you select that, then you double click on it, you can set what you want. And let me expand this so you can see everything. What the lateral offset is on the check surfaces and what the bottom offset. So X, Y, and Z. So I have X, Y of 1, Z of 5. And then with that selected, I can go choose the faces that I want to apply those offsets to. But then I can say I want another empty group, and here I want 5 and 1, let's say. And then for this one, I'm going to say it's these faces. Okay. And then from there, I'm going to turn my preview back on because I don't really need to see this calculate across the whole part. We'll bring this over. We'll bring that over. Click OK. And then here we'll have a look at the resulting toolpath. So we'll zoom way up here, and you can see how the offsets are affecting the toolpath. And where this might be useful is if you have a shutoff on a mold and you want to semi-finish that shutoff but finish everything surrounding it, then you can apply a simple little offset like this and keep on machining with nice smooth toolpath motion. Alrighty. Next one is on 3D contouring. We made a small little improvement to 3D contouring. I'll delete it and start it from scratch. So let's go ahead and go to 3D contouring. I'm going to go to my geometry, of course, and pick my text to machine. We'll go ahead and say follow the shape as well. And then back under geometry, here's where the improvement is. Notice now you have an optimization method. So you can choose how you want the toolpath to sort. For example, I want shortest path. And now Speed this up a little bit. As opposed to hopping all over the place like it used to do, or you having to select in a specific order the 3D curves to follow, now it is properly sorting the cuts. Again, little improvement, but a nice one. Okay, 2 more to go. Next one is sweeping without tail. This one is kind of unique. So here's what we have here. We have some kind of structure, okay? So we have this, this structure, it's a weldment, and then we have this part we have to machine once it has been attached to the weldment. Now here is the challenge. If you just straight machine this, for example, using sweeping, right? Sweeping works fine, but let me get back to here. You'll notice that our tool is colliding because that's the nature of sweep, right? It's the nature of sweep if you don't tell it to check. So you have to remember, sweeping is an implicit toolpath strategy. So you come into here, and of course you turn on automatic check faces. Click OK, that should solve the problem, right? And it does, it really protects those walls well because it's actually going to wind up calculating nothing. Why? The reason it's calculating nothing is because when you turn on automatic check faces, it's checking everything laterally as well as what's above it, because it doesn't know not to. So it's just checking everything. And because line of sight, that's in the way, it trims off the toolpath. Okay? So the improvement here is you have a little sub option here called Enable Computing Without Tool Tail, and that means don't look up. Only look at lateral faces. So I can turn that on, click OK, and now it's going to look at the lateral faces, trim up the toolpath properly, and you have a nice clean toolpath without collisions, and of course without violating the weldment above it. This could also be handy in cases of using sweeping in ID features on a mill turn machine, for example. Okay. All right. The last major 3D improvement that we're going to talk about today has to do with planar face machining. Again, I don't know if many of you know of the planar face machining command, but let's go over it. Let's delete this. We'll start it from scratch. So under 3D here, under others, you have something here called planar face machining, which is a great command. It goes out, finds every single planar face on the model, right? But what if you only want specific planar faces machined? Well, under the geometry tab where you select stuff now, you have the ability to filter. For example, I want to select faces by color. Notice it's automatically in the teardrop mode, so I can go up and select that face, hit my green check, and it has found all of those specific faces, hit my green check, and now it's just going to machine those planar faces. So again, nice simple improvement. That selection by color works in methods as well. For any of you doing automation, that can be a handy way to make sure everything gets taken care of. Well, that about does it for the what's new for major improvements for the 3D milling this year. If anyone has any questions, I'd love to answer them right now. Otherwise, I thank you for attending, and be sure to register for next week's webinar on 4 and 5 axis improvements. All right, I'm not seeing any questions popping up, so I'm going to go ahead and end the webinar. Again, thanks to everyone for attending, and hope to see you at next week's webinar.